Multisim Lab Common Emitter Amplifier tutorial. So how to give the connections using Multisim, I will explain. So for this first we should know this. So here you can see this is the circuit for common emitter amplifier. So for this first we need to open the Multisim. Need to open the Multisim. So after this, so you can see this that is, these are the basic. In all groups all the components are available, you can check it. So this option is available at place, right left side top corner, you can see this, click on place, will get all options. So in the sources, all sources are available, like supply, ground, everything will be there. So depends on the requirement, you can check it. So similarly resistors are there, basic resistors, ground is there, supply is there in sources. And coming to the components, you can see this transistors are available, the same here only, here itself all are available. We can click on this, click on resistor and you can place it. Just click on resistor, you can place it. If you want to change this value, just double click on that and we can change that value also. So once you have taken, if you want to change the value, you can double click on this and you can change the value also even. So like this one, it requires that is 4 to 5 resistors and 3 capacitors and 1 transistor, 1 supply, 1 ground and 1 CRO for output, 1 function generator for the input. We need to place all the components. For that, click on the place option and you will get all options. Resistor option is there, capacitor option is there, and everything is there. You can click on that and just place it. Click on that and place it. After, so here you can see this, how to take that is BJT transistor. Here you can see the select transistors, in that BJT NPN, in that BC107. Click on OK, we'll get the transistor. So like this we can take, I have taken all the components by click on place option in the left side corner. So after that we need to click on the connection, we need to give, if you want to rotate the components, just right click on the components and clockwise, move towards 90 degrees clockwise, rotate clockwise option is also available. And so like that we can click on, right click on that and you can give the connections. And here you can see this supply is also there and the same options, place option, click on place option, in that the sources are there, click on that and give the connections. If you want to change the voltage, double click on VCC and it is connected, that is changed to the 12 volts, and ground is need to give the ground connection. And input side, that is function generator is required. Right side options are there, so many options, multimeter is there, function generator is there, 2 input. I am taking 1 function generator. Then we need to go for oscilloscope to get the output and input also. We can see that using that you can place it. So these are the input outputs and give the connection. Same, click on the wire and give the connections. Ground is connected to ground, and again, and function generator input to millivolts I am giving. If you want, you can change whatever you want, you can give the value. by double click on the function generator. Similarly, and output also we need to give the connections using CRO. There are two channels are there. From A I am giving to the input, and from B I can see I will give the connection to the output side, means here across the C3. Across that is C1, we will give the connection CRO input for that is across C1 at the C1. So then give the connection, and these are the right side options are ground connections. And if you want to change the resistors, we double click on the resistors, predefined, if it is predefined circuit, if we have, so we can change the resistor values by click on the resistors. If we want to change the capacitors, double click on the capacitor, will get like this, and you can change manually. Here also I am changing, double click on the capacitor and give the 10 microfarad and click on OK. And all the connections are over here. Then we need to right side top green color option, click on that, will get, and click on the CRO option, will get the output like this. And here you can see this scale is there, you can click on that to differentiate, and to stop the signals movement, just click on signal option, it will stop the signal. So in this, one is the input and one is the output signal. If you want to change the colors also, just right click on the output, and here color is option is there, you can click on that. And preferred net name also, we can change the net name for the output also here. And so one more color, blue color I have given, and then click on OK, and then again run it top side. First we need to stop it, then again we need to run it. Here this is the green button is the, and again I am changing one more V out on node name, and the color is also changed. Now we can see this, one is input, one is output. And here again, if you want to change, here you can see this, if you want to increase the voltage, the scale option is there, students, you can click on here, it will change. And if you want to stop the signal, and click on the signal option will stop the signal. So in this, one is input, one is output, you can check it. Signal A, what is the, in channel A, what is the channel A is, that is channel A is input, channel B is output. And again I am changing the color to get the output clearly. Yellow color I am giving, so yellow color I am giving. So now we can see this easily, you can distinguish between them. Now we can see this, you can see this here, you can see this. So one is input, one is output. Channel A is input, channel B is output. If you want to change the visibility, so we can click on scale option, or if you want to move from up and down directions, means, so you can click on here, that is Y positions in that case. So like this we'll get the amplified output anyhow. Then we need to go for, that is transient analysis. For that we need to go for simulate option, and analysis and simulation, here AC sweep, click on that. Then I am giving, that is set starting frequency in megahertz, 10 hertz to, that is 10 megahertz, and sweep type I am giving, that is decade, and 1000 linear, we need to go with linear. Then click on output option, here click on, here I will show you again, Here I am showing again. You can see this. After this linear option, you can go with output option. You can go with output option. Then here you can see this add expression is there. Add expression. Click on that. Then you will get like this. Then 20 multiplication with log of closed bracket V0 by VA. So V0 is what node you have given. The V0 is given, that is V0. Node name you have changed, that is V0, divided by Vin is changed to Vin, that is V. We need to select here only. You should not write by your own, because it will not take and we will not get the transient response. So then after closed bracket, then click on OK. Click on OK. And just run it, and we'll get the transient AC sweep like this. And here also we can find, that is 3 dB frequency. And so here you can see this. What is the maximum voltage? You can drag this here. We'll get 2 options. First we need to find what is the maximum gain, and maximum gain you can check it. Here it is 79 is there. X2 value, that is 79 is there. 79 means that is 79 minus 3 dB frequency means 76 only. So we can say this here. You can check this. Here this is the 76. Y2 you can check this board, that is Y2 76, and this one also should be, Y1 also should be 76, because 79 minus 3 dB, 3 means that is 76. You can check this. So from here to here, this is the bandwidth for the given circuit. This is so this is like this. You can check even bandwidth also, that is. Thank you.